Well, what the heck? It's concentration time. Kids, where in the hell is my pen? Oh, there it is. Okay. Concentration time. Molar concentration has a formula. Concentration is equal to N over V. Now, you don't have to use the formula because you can just use unit analysis and keep moles on top and volume on the bottom. A mole goes back to Avogadro's number. It's that 6.023 times 10 to the 23rd like atoms per mole. So it's the amount of like stuff. It's also what we use in chemistry to do real chemistry, because a mole, because you don't lose atoms in a reaction, a mole can be changed from one type of mole to another type of mole. And we've already done that using mole ratio. But the formula concentration is N over V. C is mole per liter. N is mole. V is volume. And volume in this case should be measured in liters. Okay. Now, I'm not going to use that formula, but that formula is there if you want to use it. I'm going to be using unit analysis and a toolbox system. So if you want to use the formula, ka-chow, it's right there, but I'm not going to use that. So reading this, now these start off really simple. What's the concentration of a solution that contains 0.25 moles of HCl? Okay, so we write down what we know. Then you might say, how do I know this isn't a part per million question? Well, what the heck, guys? It doesn't say parts per million in it. Somebody's like, oh, somebody in the back, but you guys aren't here because of coronavirus. Somebody's like, hey, what's the percentage of this question? What is it? Well, does the question even ask for percentage? It doesn't. So you have to use a different tool. And the tool that we're using here is unit analysis. We got 0.25 moles and 0.350 liters. Okay, do you see how I converted milliliters into liters? You go 350 milliliters times magic, and it turns it freaking metric. You guys should know how to do this. If not, I'm going to come to your house and give you coronavirus from me. No, just kidding. I don't have coronavirus yet. So to get concentration, I'm just going to go 0.250 mole. Oh, look at that. I threw an extra zero in there. It doesn't much matter. Over 0.350 liters. Okay. So we divide those two out, and we're going to get concentration, because mole divided by liter gives us moles per liter. Can't do that in my head. That gives us rounded to 2 sig figs, 0.71 mole per liter. Super easy, right? We're basically just taking one number and dividing it by the other. Okay. What is the concentration of a basic solution that has 1.8 moles and 2 liters of water? Write down what we know. 1.8 mole, and we've got 2.0 liters. Concentration is mole over a liter. Okay, so it's not any more difficult than that. 1.8 divided by 2 gives us to 3 sig figs, 2 sig figs, 0.90 mole per liter. Okay, pretty simple. So mole divided by volume gives us moles per liter. Do things get a little bit tougher? Sure, because in this question it's asking us for liters. Write down what you know. 6.0 mole, 0.250 mole per liter. This question's asking us to solve for liters. Where is our liter variable? No. Also no. Oh, there it is, but it's on the bottom. So what we can do is we can flip that. A liter over 0.250 mole times by 6.40 mole over 1. Moles cancel. See how I did that? I flipped the concentration to get liters on the top. Then I'm going to have, is it really 6? Holy hell, that's a lot of moles. Why are there so many? Okay, 6.40 mole divided by 2.25 mole. Oh yeah, the liters are on top. What am I doing? Let's just do the math. 6.4 over 0.25. Okay, so that's what it is. How many liters is that? 6.4 divided by 0.25. It gives me 25.6 liters. Right? 25.6 liters. Okay, let's try the next question. It says blah, blah, blah. Uh-oh. Okay, so let's go back here and just recap. So you can solve for liters by flipping this and getting liters on top. and then it's like a dividing question. Okay, now the second part of this is a little bit tougher because now we're mixing in mass. Now, if you remember back to the gas law unit, what goes with mass? Answer at home, molar mass. What's that in the back? Molar mass. What's that? Molar mass. Molar mass. Molar mass. Molar mass. Mass and molar mass go together. So calcium chloride is CaCl2. We have these variables, 1.45 liters, 3.77 moles per liter. And because mass is required, I need the molar mass of calcium chloride. Calcium is 4008. We've got 2 chlorides, 3545 times 2, sorry. Our other variable is 110.98 grams per mole. Okay, so those are our 3 variables. And I don't need molar mass in this question right here because nowhere, you guys can't see me pointing, nowhere does it say that I need mass, but I need molar mass here. Okay, so if I'm using this question, it's solving for mass. Where is my mass variable? There it is. So that's what I start with on top. 110.98 grams per mole. Now I got to use unit analysis to get rid of everything else. All right. Concentration comes next. 3.77 moles per liter. And then 1.45 liters on top over 1. Liters cancel, moles cancels moles. Just like all of the other unit analysis that we've done. So we times out the top. 110.98 times 3.77 times 1.45. My mass to 3 sig figs works out to be 607 grams. So a little bit different. When we have mass, you need molar mass. Again, some people are going to go at home and they're like, how do we know not to use the part per million formula? Well, ask yourself this question. Does this question even talk about part per million? And if the answer is no, don't use the parts per million formula. Does this question ask you for percentages? If the answer is no, then don't use the percentages